This next question is by Koketso Boseja. And thank you for sending this in, Koketso. Here we go. It says that the light skin color is controlled by a dominant allele D. Okay. Jack is homozygous for skin color. So here's Jack. And Jack is going to be homozygous. But now, before we do anything, okay, it says the diagram below shows the inheritance of skin color in a family. Right. Look at the key. That's number one, is you look at the key. So the key, light, and that's normally a square represents the male, and a circle is a female. And then the dark male and a dark female. Okay. So circles are always girls and the squares are always the boys. Alrighty. Now it tells you that here it is light and that is dark. They also tell you, this is all the information they give you, the dominant allele D, alright, is the dominant allele D. So your recessive allele will be a small d because they tell you your dominant allele is represented by a capital D. Okay, now also we've got, if we look at Jack, Jack is not shaded. He is not shaded, you see. He is a clear square. So with the clear square, remember that it's dominant. So you are now going to see a clear square or a clear circle, and that is going to be represented by either homozygous DD, so both alleles are pure and dominant, or heterozygous DD, so this is homozygous dominant. And this is going to be heterozygous. So one dominant and one recessive allele. And please remember that when in a heterozygous situation, when you have complete dominance, in other words, there's not an intermediate trait that comes through, okay, then it means that your dominant allele literally masks your recessive allele. So you don't see that it's there. It masks it completely. Okay, so let's have a look here. Remember, if they're blank, it means they can either be dominant, so DD, or heterozygous, capital D, lowercase d. All right, so let's get a... Okay, so now what would, and I'm going to use this blue. Okay, so what would Jack be? And they tell us Jack is homozygous for skin color. So if he's homozygous, he's going to be homozygous light. And if he is homozygous light, skin, it's the light skin, he is going to have to be capital D, capital D. All right. And this little guy here, Z2 is dark. I mean lady, Z2 is dark. And in order for the dark recessive allele to come through, she must be lowercase d, lowercase d. So Jack is homozygous dominant and Z2 is homozygous negative. So we now need to go to the parents. So let's work from the bottom up. So this is the first generation. So this would be your P1. That's your second generation. And this is going to be your third generation. So your third generation line runs through this one, this one, this one, this one, and that one. Second generation will be Paul and Jack because Z2 isn't part of this family. And the first generation was Sihle and Tandi. They had babies. All right. Now, the fact that Sihle and Tandi have produced Paul, and Paul, being dark, has to be recessive, so Paul will be lowercase d. That means that Sihle and Tandi, well, they are either going to be capital D, oh no, they're not going to either, they have to be heterozygous. Why? Because where else? This D has to come from mom, and that one's got to come from dad. So one allele from mommy and one allele from daddy. There's daddy's allele and there's mommy's allele, so they are heterozygous. Jack got dad's dominant allele, and mom's dominant allele gave him his 2 there. Okay, and also the first thing you're going to do is you're going to mark all your recessives, all the recessive alleles and your recessive individuals. So Toko is a female that is dark, so therefore she's going to be recessive. Okay. Also, you've got to remember that since Jack is homozygous dominant and Z2 is homozygous recessive, it means we have a problem here. This diagram cannot be correct, and I'll tell you. Oh, it can. All right. And then Cindy, Petro, Jane, and Sipo are all heterozygous. They would have got the dominant allele from Jack and the recessive allele from Z2. So there we go. And we've just done the whole pedigree diagram. As easy as that. So the first thing you ever do is you mark off all the recessive alleles. That's it, your recessive individuals. Because for the recessive trait to come through, they must have 2 recessive alleles, one from mom and one from dad. And look at this. If they got one from mom, one recessive allele from mom and a recessive allele from dad, then mom and dad must be heterozygous. Okay, so here we go. Define homozygous. People, homo means the same. Zygous talks about the alleles. So it tells you that both alleles are the same. Okay, so we do this. Okay, so for question 1, homozygous, both alleles will represent the same. And you can either say trait. Trait is easier to spell. Or you can write characteristic, which is such a long word and means the same thing. So they have the same. So, and I'm going to, that's what you're going to get your marks for. But let me put this like this. You can say if it's homozygous dominant, okay, that means that they're going to be, that the individual will have 2 dominant alleles for that trait. Okay, and if it is homozygous recessive, well, it's exactly the same, but you have 2 recessive alleles for the trait, and both are pure breeds. And that's important. They are both pure breeds. Okay, so don't think because if something is recessive, it's not pure, and only dominant is pure. Dominant is pure and recessive is pure, as long as they are homozygous. So we talk about homozygous dominant, 2 dominant alleles, homozygous recessive, 2 recessive, and so 2 dominant and 2 recessive alleles for the same trait. Okay, so we've done that. But remember, homo means the same. Okay. Homo is same, and zygous, both alleles. So they're pure breeding. Okay, now give possible genotypes. Now remember, genotype tells you what's in the genes. And it's what's in the genes that determines the phenotype. Okay, so, and that is why Lamarck's theory of use and disuse and law of acquired characteristics is all bleh. It's nonsense. Why? Because it has to be in the genes for it to be even visible in the phenotype or masked in the phenotype. But if it's not in the genes, you can't, no organism can make something that is not in the genes. It has to be written, there's got to be a code in a recipe. Because remember, your DNA is like this mammothly big recipe book. And in that recipe book, it's got the recipe for every little tiny thing that you are as a human being. Or if you were an ant, as an ant. Or, I don't know, pick an animal, pick a plant. All of it sits in the DNA, in the nucleus of every cell of that organism. So it has to be in the genes. Okay, so genotype, what's in the genes? Phenotype is what is visible physically. Okay, that's your phenotype. Phenotype is what you see. Genotype is what is in the genes. So you could have black hair, okay? But you could have a baby that has blonde hair. And or, like we look here, you could have, here, Sichle and Tandi both have light skin, okay? But look, they have Paul that has a dark skin. And Z2 has a dark skin, Jack has a light skin, and they have 1, 2, 3, 4 children that have light skins and 1 child with a dark skin. It's what is in the genes is what you can see physically. If it's not in the genes, not going to happen. So, okay. So if we look at Paul and Cindy, what do you think Paul is? So Paul, where's Paul? Paul's here. He is shaded immediately. The fact that he is a shaded symbol tells you he has 2 recessive alleles. So Paul is going to be DD. That's his genotype. And Cindy has to be heterozygous. So she's going to be capital D, small d. And remember, she's heterozygous because she got the dominant allele from her dad, Jack, and she got the recessive allele from Z2, her mommy. All right. So Tandi's expecting a 3rd child. There's Tandi. So Tandi has Paul and she has Jack. And remember, Tandi and her husband Sichle are heterozygous. Okay. What is the percentage chance of giving birth to an offspring with a dark skin? Well, let's have a look. It's going to, I can tell you now it's 25%, but I want to show you how I get the 25%. Okay, so we take the 2. So it's still the P1. The P1, we have the genotype. Oh, no, let's do phenotype first. Your phenotype is light skin times light skin. Okay, the genotype, look, you're not going to have to do all of this, hey? I'm just showing you how. So light skin, but we know that they're heterozygous because they had a child that was homozygous and heterozygous. So there we go. And now we have meiosis, and we have our gametes, our little Punnett square. So these would be your gametes. And I'm going as fast as I can. Capital D, lowercase d, capital D, lowercase d. So DD, that would be homozygous dominant offspring. 25% chance. Okay, or 1 in 4. Okay, then we have capital D, lowercase d, capital D, lowercase d. So capital D, lowercase d gives us a 50% chance, which is a 2 out of 4. And look here, little d, and there is your 25% or 1 in 4 chance that they will have a dark-skinned child. And we've just answered our question. Okay, now explain why the offspring will always be light if he or she inherits 2 different alleles of the skin color, as I've explained to you already. When it is heterozygous, so that's what they mean here by 2 different alleles. If it's 2 different alleles, it means you've got a dominant allele and a recessive allele. It's because the dominant allele masks the recessive trait. Okay, it masks that recessive trait. So you're not going to see it. All right, then identify the child that is adopted by Jack and Zitu. So let's see here. Which child is adopted here? So you've got Jack and you've got Zitu. It's clearly Toko. And why would it be Toko? Well, Toko has a lowercase d and a lowercase d, which means a recessive allele and a recessive allele. And Jack does not have a recessive allele. All right, remember, you need one of the alleles from the dad and one of the alleles from the mom. Where did the second D come from? So Toko is adopted. And then give a reason for your answer. I've just explained it to you.